In this video, I'm going to go over the basics of the new gantry mode that's available with the AKD2G dual-axis drives, and I'm also going to go over a new template program for the KAS IDE EtherCAT master controllers when using an AKD2G drive in gantry mode with a KAS controller. So this has extra components, extra function blocks on top of our normal template program and extra objects in the control panel that will allow you to turn the gantry mode on and off, so that if it's off you can give separate commands to home axis 2, or if you need to move it in position, and then you can turn gantry mode on, whereas then axis 2 will always follow the same position commands, and basically everything that axis 1 does, from enabling, disabling, clearing faults, moving, axis 2 will do as well while gantry mode is enabled. So I'm going to go over the basics of gantry mode while I'm in the Kollmorgen Workbench application. We do have Workbench integrated into the KAS IDE software, but a few of these parameters aren't shown. For instance, you can't change the command source inside the KAS IDE, so I'm going to demonstrate it connected directly to the AKD2G drive's service port and using the separate Kollmorgen Workbench software. So the big change with the gantry feature is now with an AKD dual axis drive, you do have to have the dual axis because you need to have one axis be the master and one axis be the slave, which you can't do when there's only one axis per drive. And for axis 2, the axis 2 command source, now there is a new option, option 4 for gantry. And when you put axis 2 in gantry mode, what happens is it will just follow whatever is commanded to axis 1. So if you command to enable axis 1, axis 2 will attempt to enable. When you disable axis 1, axis 2 will disable. When you command to move to axis 1, the exact same move, the exact same time will be commanded to axis 2. This is described more in depth in the Workbench online help, and there also is a separate KDN article titled AKD2G Gantry Application Setup that goes into much more in depth on tips on how to set this up. Here's the block diagram showing how, yes, the axis 1 position command is automatically shared with axis 2. It goes over some examples, tips, tricks, and more details on all the new keywords in the AKD2G to support the gantry mode. The big one that I'll go over in the KAS template program is gantry.pl.err. This is a new position error, so it's not the difference between command and actual positions, it's the difference between actual positions reported between axis 1 and axis 2. This is because with the gantry we're giving the same position command to both axis 1 and axis 2, so if they're not at the same position, that would consider to be an error on the gantry. You could have the actual mechanics not be aligned, and that wouldn't be great for your mechanics or your performance. So, also of note, when you're using a KAS application, you can't have axis 2 be in gantry mode to start right now. If you had axis 2 in gantry mode and you try to start a KAS program, the EtherCAT network wouldn't be able to get up and running, and that's because when axis 2 is in gantry mode, it's blindly following what you're commanding to axis 1. The EtherCAT master controller then wouldn't be in control of the control word for axis 2. It couldn't enable, it couldn't disable, so you would have to start to have the axis in field bus mode. Now the default for KAS is to automatically put axes in field bus mode, but just note if you try to change that or override the COE and init commands in your KAS project in order to start at a different op mode or command source, that you would get an error. So what I have done in the template program that I'm going to go over next is that you will start in field bus mode, but then through the control panel you can switch axis 2 into gantry mode when you're ready. Typically you're going to want to start in field bus mode anyway in order to make sure that the axis is homed. You can command separate position moves to each axis if you're ready to enter gantry mode. So I'm going to focus going over this new template application that I wrote for the KAS IDE software for use with the PDMM or PCMM controller, which is an EtherCAT master, and it will only work with an AKD2G dual access drive because that's the only drive that currently supports our gantry mode, because you do need the 2 axes on one device. And so this is a bit different than our normal template program. First difference you see is there's not an overall enable button. We split it up because you may want to enable each axis separately and have one disabled, especially while you're homing. If they're physically connected through a gantry, you might want to only enable one at a time so it can move, and then move the whole gantry, and then the other won't be enabled and fighting the other one from moving. So yeah, now I can just flip a switch, and if axis 2, as currently you can see, is in field bus mode, not gantry mode, so that when I enable axis 1, axis 2 will not be enabled. So I can separately enable axis 2 and give it its own single axis jog motions, relative move, absolute moves, or I could just run a whole home routine separately for each. But then if I do click this button to write axis 2 command source to 4, which is for gantry mode, then if I double check through Workbench, we'll see that this was successful. Now the axis 2 is in gantry mode. And what really happens is there's a separate structured text program called Gantry that has a number of write SDO function blocks. So there's one for both axis 1 and axis 2 on the AKD2G, but really you're mostly going to be just changing the command source for axis 2 between 1 for field bus mode, where you want to give it separate single axis commands, or 4 when you want to engage gantry mode, and then it will just always follow whatever you command to axis 1. We also have other down here tied to different buttons on the control panel, which I'll get into in a little bit, but they're all contained in this gantry mode. There also is a separate structured text just for a full home routine that I wrote for specific mechanics that I have on my desk. So this will make sure that axis 2 is taken out of gantry mode, then it will home each axis, but make sure that when one is moving, the other one is disabled so they won't fight each other. And then before going back into gantry mode for axis 2. So you can certainly feel free to look at this and try it, but you may have to redo this to customize it for specific mechanics or the gantry that you have. But everything here is more generic, just to access a single AKD 2G parameter. So once again, there also is a button to home RDP that does this RDP homing routine, because it's for a RDP demo unit that I have as testing. And then these other buttons are tied to function blocks, write STO function blocks in the gantry program. So I clicked the write command source for axis 2 to 4, so now gantry mode is enabled. Now if I try to do anything for axis 2 to give the single axis enable jog command, nothing happens because it's ignoring it. But if I tell axis 1 to enable, both axes are now enabled. Because gantry mode's enabled, whatever we tell axis 1 to do, axis 2 will also do. So now if I jog axis 1, both of them will move, so they will work together to move the single load, or to move the entire gantry. Also, I mentioned that there is a new position error that's gantry level. So it's not the difference between command and actual positions, it's the difference between actual position of axis 1 and axis 2 on the drive. So here I have, this is actually doing a read STO, not a write STO, so it's just reading that parameter from the drive. You can monitor to see if it's getting out of touch with each other. If it is, and you're getting drive faults that you try to clear, but they immediately come back because just something's out of whack, with the mechanics of your system, you can click this axis 1 home.set. This was actually does a clear reset of the position feedback actually on the AKD drive. It's different from this set 0 button, which just clears and offset at the controller level. So if I disable, do this home set, turn it back on, check the position there, now it's much closer to 0, even after I move, just because I did that home set. So Something else that I ran into in supporting customers that were using gantry mode with EtherCAT or different field bus masters such as KAS. Sometimes you may have to reset the position at the drive level, not at the controller level. So that's the basics differences that we have with this new template program. So this is up on KDN, and once again I will also link back to this separate KDN page, which has a more detailed document of just setting it up on the AKD2G drive, not necessarily with a KS master controller.